Hi everyone, I'm Setareh Farokh. Amin, a 14 years old student from Tehran, Iran, who recorded this video to participate in ISAC International in Science and Art. And here, I'm going to tell you one of my problems in ISAC Tournament 2023 that the name is Chemical Countdown. And interesting things such as experiments gonna happen in this video, so stay with me. The question that our problem told us is, if solutions of potassium permanganate, sulfuric acid and oxalic acid are mixed, the mix discolor after time interval. Is it possible to adjust the amounts of the materials so that the mix discolor after time interval is specified by your opponent in the science fight? In order to solve this issue, we have to go through a path, and in this path, we talked about at first introduction, after that theory, experiment, conclusion, and finally references. Introduction, and the first part, brief description of issue. When three substances of potassium permanganate, sulfuric acid and oxalic acid are come together, the color of mixture change after some time. The amount of potassium permanganate, sulfuric acid and oxalic acid should be determined in such a way that values will color change. And the aim of this test is to determine the values to observe the color. Now about past experience. In 1814, Joseph Gay-Lussac developed a similar method to determine coloring in bleaching fluid. In both methods, they have equivalence or endpoints with color change. Before the equivalence point, their solution becomes colorless, and after that, nil reacts with and gives a fixed color to the solution. And about keywords. At first, we are going to talk about titration, redox titration, manganometry, and normality titration. It's time for our theory part. What is titration? Determining the concentration of an unknown solution with different methods called titration. A common quantitative laboratory method in chemistry is analysis, which is used to measure the unknown concentration of an titrant. We have two forms of titration, acid and base titration and redox titration. In our solutions that we have in our problem, we don't have any strong acid and base solutions, but we have a standard solution of oxidizing or reducing agents like oxalic acid and permanganate potassium. So we can say that our titration is redox titration. And in this part of theory, we want to talk about two main solutions in titration that's called titrant and analyte. Titrant is a solution with a known concentration, and analyte is a solution with a known concentration that we have reaction between analyte and titrant, and after that we can know the concentration of an analyte. An analytical technique that involves redox titration using potassium permanganate, and it used to determine the analyte or oxalic acid concentration named manganometry. And here about normality in titration. We can say that two concepts of normality and molarity can be used to calculate the concentration of substance in titration. And we have formula here. N1 multiplied V1 equal to N2 multiplied V2. And if I want to explain more this formula, I can say that N1 is a short form of normality of oxalic acid, multiplied V1 is a short form of volume of oxalic acid, equal to N2, that is our normality of potassium permanganate, multiplied V2, that is our volume of potassium permanganate. And after all, now we have the interesting part here. Experiment. At first, the material and equipment that we need is 0.1 mol of potassium permanganate, a standard solution. Number two, we can say that unknown solution of oxalic acid. After that, we need sulfuric acid solution, as the picture that you can see, distilled water, jujube balloon, pipette, burette, airline, graduated cylinder, heater, and dropper. In this part of experiments, I want to talk about my method. At first, I prepared the important things that I need to do the testing. Number one, my titrant. To make this solution, I need 100 ml of distilled water with 1.58 of caminophore, and then mix it together to have a standard solution of potassium permanganate. Then I fill my burette with this solution up to the 0 point and connect it to the burette clip. Number two, our analyte. At first, I add 10 ml of oxalic acid with unknown normality and 6 ml of sulfuric acid. Then our analyte airline is ready too. So let's do the testing and experiment in another slide. In video, you can see after I prepared everything that I need to do this experiment, as I told you, I placed the air line on a heater 16 to 70 degrees that my solution doesn't boil, and after that I add a few milliliters of potassium permanganate into the analyzed solution by burette, but something special happened. The deep purple color of potassium permanganate became colorless in analyzed solution. But after I add more and more few milliliters of potassium permanganate, you can see that the color changed into the light purple, purple, and deep purple. In fact, I continue to add potassium permanganate until the oxalic acid completely runs out. I mean, we can see the deep purple color on the analyzed solution, and after that I write the amount of potassium permanganate that I used to have this color. And finally, the last part of experiment, data. In this chart, you can see that at first oxalic acid is active in the container, and after equivalence points, the oxalic acid consumed and potassium permanganate is active now. After experiment, it's time for analysis. We have the volume of oxalic acid, our unknown solution, and it is 10 milliliters. And for potassium permanganate volume, we can say that by experiment we understand we have 1.4 milliliters of potassium permanganate, a standard solution from burette, and the normality of it is 0.1. And finally, by do this formula, we understand that the normality of oxalic acid is 0.014. And now about the time. In general, the speed of the reaction and time duration are same. Therefore, human factors such as burette setting can be effects in the time when we can see the color change or equivalence point. For example, here in this diagram, I set the burette as drop by drop, and I have 10 milliliters of oxalic acid and 1.4 milliliters of potassium permanganate. And the time that it takes to the equivalence point is approximately 4 minutes. And when I double my values by this burette, I can see that the time that it takes is 10 minutes. And here, the burette informally set and the value is 10 milliliters and 1.4 milliliters just take 1 minute to the equivalence point. And with doubled values, the time that it takes is the same. So you can see in this chart that the amount of time and volume of values have a direct relationship. So we can say that we can calculate the time by values, and in short, because the reaction speed is same, the only factor that is effective in the duration of the time is human factor, and in this experiment is burette setting. You can see in this slide that we did this test twice to reduce the error, and here we have 10 milliliters of oxalic acid and 1.4 milliliters of potassium permanganate, that is the exact amount from 0 points. Single reaction, we can say that the reaction equation of potassium permanganate with final oxalic acid is
2COMnO4 plus 5H2C2O4 plus 3H2SO4 is equal to 2MnSO4 plus 10CO2 plus 8H2O.
Here in this chart, you can see finally values option to carry out the reaction. At first, we have C2H2O4, that is our oxalic acid, and the value is 0.014 milliliters. And after that, we have COMnO4, that is our potassium permanganate, we have 0.1 milliliters. And after all, we have H2SO4, that is our sulfuric acid, and we have 6 milliliters of it. And after doing this test with these values, our opponent will completely notice the color change in the science part. And it happens. By these values, we have this deep purple color that is specified. So, we win the science fight. Congratulations! And as I said, this path ends with references. Here is my references, but 1 minute. Finally, a million thanks for watching this video until the end. I hope you enjoyed it. Setareh Farokh Amin, ISAC Olympiad in Science and Art 2023.